All right, section 10.6. Let's put a circle on here. We already talked about tangent. Let's just review very briefly. So a tangent is a line, right, that hits the circle where? Boom, right there. Just at what?
Right on
1 point. 1 point, okay? So a secant, gave it away. The tangent, okay, is a line. So technically it's a line. Now sometimes we'll take that line and we're not going to consider the whole line. Sometimes we only consider like a point outside the circle to the point of tangency. All right, it's still considered a tangent. The whole line itself is still considered a tangent, okay? Now we got another line. Let's do this in different colors since it's new. But this line doesn't just hit at 1 point, it actually goes through the circle. So how many points is it going to hit on that circle? It's going to hit at 2 points on the circle. So there and there. So it hits 1 point, 2 points. That right there has a special name, and they call this a secant. S-E-C-A-N-T. This, of course, was a tangent. I'll just write that down. So a tangent only hits the circle at 1 point, intersects a circle at 1 point. The secant is a line that intersects the circle at 2 points. Somebody asked me in the other class something about can you have a line that hits it at 3 points? Can you have one line that hits a circle that intersects a circle in 3 different points?
No.
No, you can't. All right, it wouldn't be a line, would it? I think somebody was thinking, oh, it could curve around, right? But
it wouldn't be a line.
it wouldn't be a line then, would it? It'd be a curve. You said parabola, right? Well, that only hits at 2. Let's do it like this. Watch. You could do a parabola, something like that. But that's not a line, though, is it? All right, so it has no name as far as this stuff is concerned. So these are all straight lines. And that's a secant. Hits the circle at 2 points. Everybody good with that? Yes? Okay, good. Let's talk about a secant, and let's do a couple theorems about a secant, and we'll see what we can do with that. Okay, so here we go. We got a nice circle. We got a couple secants. Now I didn't draw the arrows on here. Technically, there should be arrows on there that keep on going, but I'm just not gonna. It's just a waste of time. All right, just pretend there's arrows on here. Now look what's happened here. What I want you to do is I want you to see. Let's go like this. Let's take a look at this angle right here. This angle right here. This secant comes out this way and it comes out this way, and it cuts off part of the circle, cuts off an arc from this circle. Well, there's something special about these arcs. Let me mark it, and since I made that in purple or pink or whatever color that is, we'll make that in the same color. Now look at this angle right here. It's also equal to this, isn't it? Now let me ask you this. Is this angle equal to this arc?
Not the line.
The measurement of the angle, the degree measure. The degree measure of this angle, is it equal to the degree measure of this arc?
Yes.
Because the arc cuts, or the angle cuts off the arc, right? Cuts off. Do they cut off equal arcs? When does the angle equal the arc? That's right, when it's the central angle. Okay, so this angle right here is not equal to this arc. It would only be equal to this arc if where was the vertex? At the center. Okay, if I pulled this down to here, then the arc and the angle would be equal. A lot of people make that mistake. They see this and they're like, oh, this arc equals this angle, but it doesn't. The only way that that happens is when the vertex of this angle is at the center of the circle. Everybody with me on that? Okay. But these two angles right here are still equal to each other. Why? What's the word in geometry? They're vertical angles, right? So these are vertical angles. That does not mean, though, that the arcs are equal. Look, that's a lot smaller arc than this one, isn't it? So if the angle equaled the arc, you could see right away that there's no way that that could be true. Don't you? So what I'm going to do is, but there is a relationship, though. They're not equal to each other, but there's definitely a relationship. So here's the other arc right there. Let's label these. Might as well. Let's call this, let's not put the A out there. Let's put it right here. We'll call this A, B, call that C, D, and the E. Alright? So here's the deal. These two angles are the same, but if there was a relationship between the two arcs and the angle right here. So what happens is, if these two secants intersect inside the circle, which they do, don't they? The two secants intersect inside the circle. how do I find the arcs, or what's the relationship between them? Well, let's call this angle ACB. All right, that's this one right here. Everybody with me on that? Well, what is it equal to? Well, here's what the theorem says. The theorem says that if I add up these two arcs, arc AB and arc DE, if I add them up, it's not equal to this angle, but but if I add them up and take half of it, then it's going to equal this angle right here. Okay, the angle that forms those two arcs. Do you see it? So if I add them up and then divide them by 2, then that is going to equal this angle right here. So let's just write it out, and I'll put some numbers in here in a sec. So it's going to equal half the sum of the two arcs that those two angles cut off. So what's one of the arcs? AB is one of the arcs, right? And what's the other arc? DE, that's right. DE. Everybody see that? So that's one of our theorems. I don't care what number theorem it is. We never go by that anyway. I don't even think they give it a name. Nope. Alright, it just happens when what? When two secants intersect inside the circle. In a few minutes we're going to do two secants intersecting outside the circle and on the circle. But right now I'm only going to talk about two secants intersecting inside the circle. So if I take the two arcs that they cut off, it's going to equal, and I add them up, I should say, take those two arcs, add them up, and then divide them by 2. Take half of it. Then that's going to equal that angle. Everybody got that? Let's just make up some numbers here. I don't know. Let's say that's 40 degrees, and this is, I don't know, 70. Let's make it an easier number. Let's just say 60. We'll make it super easy, okay? So watch. If I wanted to find what this angle is, right in these two vertical angles right here, if I wanted to find this, and if I knew the measurements of these two arcs, I could very easily, if you know the formula, it would be easy, I could find this angle right here. So what do? You add them up, 40 plus 60, and then what do you do to them after you add them up? Divide it by 2. So that's 100, right? Divided by 2, and that would be 50 degrees. So if that was the case, if this was 40-degree arc and this was a 60-degree arc, then the angle in between would be 50. It's basically kind of like the average, isn't it, of the two arcs? You could look at it another way. What about this angle right here? Do you see that? Well, it cuts off an arc, doesn't it? And its equal angle, its vertical angle, cuts off an arc as well. So let me try to draw around this. This is a little bit longer. Okay. See that arc that angle cuts off? Well, what does this vertical angle cut off? It cuts off from B all the way to E this way, doesn't it? So let me try to... right there. Everybody see that? So if I wanted to write something out like I did here, if I scroll down, I'm going to run a little bit of room. That's fine. So let's call this angle right here, this yellow angle that I made, what are we going to call that? Angle what? ACD. That's going to equal half of what? The sum of those two arcs, right? So we'll just call it BE. Is that all right? BE plus what else? AD. Got it? There you go. And again, you could put some numbers in here if you wanted to. So what do? We add up the two arcs and then divide it by 2. You got it? With in this situation, yeah, if this was 40, then this would be what? 140, wouldn't it? Arc BE. Because look, this is a straight line, isn't it? So that angle and this angle, this arc goes from here all the way to here, right? It's a semicircle, so that'd be 140. So if this was 60, then this would be what? It's not exactly drawn to scale, but yeah, that would be what? 120? Is that right? So yeah, you could find this, and let's see if it works. So we said this was 50, right? So this should be 130. Let's see if it actually works though. Add them up. 120 and 140. It's 260 divided by 2, and that's what? 130, just like it should be, right? So it all works out real nice, doesn't it? So that angle right there is 130 degrees. You got it? Okay, enough of that. Now, just remember, on this one right here, when the two secants intersect where? Where do they intersect? Inside the circle. Then you add up the two arcs and divide by 2. You got it? I keep harping on that because now I'm going to have a couple. Secants. They don't necessarily intersect inside the circle. So watch this. What if I had? Let me see how they draw this thing. Okay. Now watch this. It's not just any old two secants. They have to form an angle. So they must have to come from the same point. So if they come from the same point outside the circle, see that? Because they have to intersect each other. Remember the other one intersected where? Inside the circle. This one's going to intersect outside the circle. Do you see how they come together right there? Let's let's label these A, B, C, D, and E. All right? And let's color some of these in. Make this one green, make it a little thicker. So watch. First of all, do you see this angle that's formed, angle A? What arcs does it make? What arcs does it cut off? It cuts off this arc BD, and what other arc does those two secants cut off? CE, right. So from C all the way to E. Now notice, these two secants intersect outside the circle. They don't intersect inside the circle. When they do intersect inside the circle, we add up the arcs and divide by 2. Listen to my emphasis. I'm trying to get you to think of what we're going to do next. So if they intersect inside the circle, we add up the arcs, thank you, and divide by 2. Okay, on this one, we're going to do what? We're going to subtract the 2 arcs and then divide by 2. So if I wanted to solve for angle A, I would take the 2 arcs and subtract them. Does it matter what order we subtract things in? Yes, it does. Okay, if I want to get a positive number out of it, so I do want to get a positive number because this is a positive angle, right? So I take the bigger one minus the smaller one. Which one do you think is the bigger one? Yeah, to see how it's stretching out, the further out it goes, the bigger that arc gets, doesn't it? So CE is the bigger arc, so we're taking half of CE, arc CE. Now we're not adding the 2 arcs together. What are we doing to the 2 arcs? We're subtracting them. So arc CE minus what? Arc BD. And there you go. So those are 2 secants that intersect outside the circle. You subtract the 2 arcs from each other, take half of it, and you've got this arc right here. Let's just stick some numbers in here. Let's say this was 20 degrees and this was, I don't know, 70 degrees. All right? So what do we do here? What's the math? 70 minus 20, and then what do we do? Divide by 2. So that's 50 divided by 2. What's that angle? 25 degrees. So this angle A right here is going to be 25 degrees. Make sense? All right. Let's do another type of situation. We've had 2 secants that intersect inside. We've had 2 secants that intersect outside. Now what we're going to do is we're going to have one secant, and what else did I say we were going to talk about today? A secant and a tangent. That's right. So if I had a point, watch this. If I had a point outside the circle, and there's a secant, and watch this. Boom, right there. So look, there's the point of tangency. So look, I got a secant and a tangent this time, don't I? We'll call this A, B, C, D. Right? Those are all my intersection points. And what I'm going to try to do is find that arc right up here. So I'm going to try to find an angle A. Now what I want to do is find out what arcs are being cut off from this angle. Comes out like this, comes out like this. What arcs are being cut off? BD is one arc, right? And then what? CD, this way around like this, right? So let me do that in a different color. If I could stay on the line. There we go.
Oh, that's a cool color.
Isn't that cool? All right, so look at this. So this angle right here, angle A. So let's write it down again. Angle A is equal to half. It's basically the same math. It's slightly different. So what are we going to do? What's the bigger arc?
CD.
CD. So we're going to go arc CD, what? Minus arc BD. That's right. I'm not going to put any numbers this time just because of time. All right. There you go. If I was going to find this, I take this outside arc minus this inside arc, subtract them, take half of it. That's what this angle right here is going to equal. We good with that? Very, very similar to what we just finished doing, isn't it? Almost the same thing, isn't it? Almost. Not quite. Let's do another one. Let's do... What about two tangents this time? How's that? Make it a little smaller for tangent. Let's do a point outside the circle. So if this is tangent, it hits right there. And then we're going to start from that same point outside the circle, and it's tangent, and it hits right there. So what am I looking at? There's the point of tangency. Do you see that? Forms two arcs, doesn't it? See this angle right here? We'll call this A, B, and C. So this angle, this outside angle, you've got two arcs here. Try to draw these again. Watch, you've got this big old arc out here. There we go. And then let's change this color. What haven't we used in a while? I think we're using them all up, aren't we? Let's go this orange.
What happened to that giant list of colors we had?
It was too many. I think I like a smaller number. Alright, let's take a look at this. First of all, though, I can't just say arc BC minus arc BC, can I? This one definitely looks like the major arc, so I need another point in there.
It says the same name.
Right, it's got the same name. That's why I said you can't do that, right? Because the purple one and the orange one are definitely not the same arcs, but if I just said BC and BC, you wouldn't know which one was which. So let's stick another point in here. We'll just call it point D. Is that all right? So now, what can I say? I can say that angle A, the math is exactly the same. The math is no different. It's just a slightly different situation. Half of what? Arc what? B, D, C, right? Minus what? Arc BC. That's right. And there it is. I don't know why my parentheses is so far away. There we go. Make sense? So it's that purple one minus the orange one. But half of it, right? Subtract and then take half of it. And then that's what this angle is. What are we finding? We're finding angle A. Got it? Alright. Let's do one more. Got a few minutes here. I kind of went out of order. This was theorem, that was theorem 10.14. This is theorem 10.13. But I just think it fit better in that order. This is very, very similar to what we just finished doing. What if we have, now let's jump back a little bit. Remember we had a secant and a tangent? But where did they intersect each other? They intersected each other outside the circle. Do you see that? But on this one, the secant and tangent actually intersect each other on the circle itself. So let's see what that weird looking thing looks like. Okay, so here's a circle. I got a secant and a tangent that actually intersect each other on the circle. So there we go. And let's do the tangent. If they intersect each other on the circle, it must go through the point of tangency. Would you agree? Alright, so that's the secant right there. Now you could extend it all the way out if you wanted to. It just is a little bit nicer this way just because you can see the angle that's formed. Alright, so here's the deal. Let me see what I want to say. If a secant and tangent intersect at a point of tangency, then the measure of each angle is half the measure of its intersected arc. Okay, watch this. Let's call this one. Let's call this angle 1 right here. And let's call this angle 2 right here. Do you see where angle 1 is? Angle 1 is that right there. It's between, right? It's between the tangent and the secant. You with me on that? And angle 2 would be, now it doesn't just go to the circle, it actually goes to the line. And that would be angle 2. You good? So look at this angle 1. It creates this arc. In fact, let's draw it the same color as this. Make it a little thicker. So it creates this arc right here. Everybody see that? So this angle, angle 1, creates this arc. Well, this angle is exactly half of the arc. Let's put some letters in here and we'll write that down. So we'll call this A, we'll call this B, and we'll call a point out here C. Is that all right? Because that's going to be a major arc right there. So angle 1 is equal to half of the arc that it forms. What's the arc? It's AB or BA. However, it doesn't matter how you say it. We'll go BA. Everybody with me? So angle 1, if I have a tangent and a secant and they intersect right on the circle at that point of tangency, then that angle is half of that arc. Is it making sense? I mean, these aren't hard to understand, but I tell you what, they all start piling on, don't they? And they all start mixing up, and you got to make sure you keep stuff straight. It's pretty important. So what's angle 2 equal to? Well, it's equal to half the arc that it cuts off. So it would be BC, yeah, ACB or BCA, however you want to say it. I'll tell you what, just since I've been doing this for all of these, let's do it for this one as well. Oops. And there, okay? Just kind of keep everything color coordinated here. So what's it equal to? It's equal to half of that big pink arc right there, which would be arc BCA. Alright, so there you go. When does that happen? That happens when you have a tangent intersecting, a secant intersecting a tangent at the point of tangency. So that arc, this angle is half the arc, angle 1 is half of this arc, angle 2 is half of this pink arc, and then there you go. You don't have to add anything, subtract anything, you just look at the arcs, take half of it, look at this arc, take half of it, boom, you're done. You okay with that? I think we covered everything right there. Yep. That's a lot of stuff, isn't it? Yep, it's a lot of stuff to go through. You got to keep it straight, which means you got to study it. You can't just expect to just sit and listen and get it all. You know what I mean? You've got to practice it. You got to study it. Yep. Yes. Okay.
My circles all look perfect now.
Good. You're so welcome. All right. Well, I'll have them up here, so if you want to grab them before class, that's fine. So here we go. Section 10.6. We're going to do page 732 and 8 to 23. Right there. Okay? All right, have fun with that. See you tomorrow.